Hello everyone. We are looking at phase 5, chapter matrix, exercise 1, the questions from exercise 1. So this is our sixth question. Question number 6, give an example of diagonal matrix, which is not a scalar matrix, and then give an example of scalar matrix. Okay, so this is a very much definition question. If you all remember, what is a diagonal matrix? Diagonal matrix is a matrix where the UTP or LTP or the triangular upper triangular part or the lower triangular part are essentially zero. So only the diagonal elements should exist. And if we are talking about diagonal, then we know that if diagonal we are talking about, then it has to be a square matrix. So if it is a square matrix, let's say 3 cross 3, and it has to be a diagonal matrix, meaning these 3 elements from here and these 3 elements, they essentially have to be 0. So if we have to build it, we have to start with putting 0, 0, 0 here. Now, for this to be a diagonal matrix, this diagonal can have anything, like it can have 0 or any element. So let's say A, B, and C. So this is an example of diagonal matrix. Instead of A, B, C, we could say 1, 2, 3, and then 0, 0, 0 here, 0, 0, 0 here. This is an example. Now, something which is a diagonal but not a scalar. So we also have to understand that all scalar matrices are also diagonal, but what is essentially a difference? How does a diagonal matrix become a scalar? So again, a definition of scalar. So scalar matrix is what? It is a diagonal matrix. So it is a diagonal matrix where the diagonal elements, are all equal. Where the diagonal elements are all equal. So when the diagonal elements become all equal, it will become a scalar matrix. For example, here A, B, C ke badle, if it had been, so an example of a scalar matrix could be, but not essentially 1. So 1, 0, 0, or we can say 4. So 0, 4, 0, 0, 0, 4. So this is a scalar matrix where all the diagonal elements are equal. Now, scalar matrix are, so let's say a diagonal matrix, then some diagonal matrix where all elements are equal to equal. Well, all elements are equal, it will be called scalar matrix. And now scalar matrix may be, if they are equal to 1, then it is called identity matrix. So it is a quick revision of the theoretical part. And not all elements are, so they are not called scalar. So not scalar here. And if they are not equal to 1, then they are not identity. That's it. So they are not identity. So diagonal matrix, if all elements are equal, will become scalar matrix. If the all diagonal elements are equal to 1, it will become a identity matrix. So this is an important question, not because of the question, because it just revises our basic concepts and definitions of matrix. Okay. Thank you.